Okay, so we were talking as a set of teachers about the Pythagorean theorem recently, and we found that in talking to our students, many of them don't feel very confident about using the Pythagorean theorem. Our textbook sort of assumes that you're all very good at it, you're very well versed at using it, and that's maybe not a fair assumption. Some of us haven't really had a lot of chance to learn the Pythagorean theorem. Or, maybe it was addressed shortly, but then our teachers just didn't really spend much time on it. And some of us are better at it than others. So let's just take a quick look at the Pythagorean theorem, what it is and how it's utilized. So let's talk about first off what the Pythagorean theorem actually says. So the Pythagorean theorem says if a right triangle has legs A and B. Now, it's important that when we talk about the legs of a right triangle, they be the two sides that are next to the right angle. So we could call this one A and this one B, although we could reverse them. The legs of my first problem that I'm going to work on with you are 8 and 5. The legs on the second one are 3 and 6. Sometimes people mess that up. Remember, the legs are the two sides that are right next to the 90. The next one on number 4 with the legs would be Z and 12, okay? So, or 12 and Z. So if it has legs A and B, then if you square the two legs, that's A squared and B squared, and you add them together, their sum is equal to the square of the hypotenuse. This side right here is known as the hypotenuse. And the hypotenuse is always the longest side and is always directly across from the 90 degrees, and we usually call it C. The hypotenuse of my number 1 is going to be C. The hypotenuse of number 2 is X. The hypotenuse of number 3 is going to be 10. The hypotenuse is that one across from the 90, also the longest side. Now, this is the part that is really interesting for a lot of people, is they don't realize that the Pythagorean theorem is a two-way street. That if the right triangle has legs and this one works, but it also goes backwards the other way. That if A squared plus B squared equals C squared, if you can actually make it work, then we have a right triangle. A right triangle with legs A and B, with legs A and B, and hypotenuse C. Sorry about my penmanship getting a little sloppy. I'm trying to fit it in. So we're just going to do a couple of quick examples. So the Pythagorean theorem says leg squared plus leg squared. Started actually writing it down. Just a kidding. Hold on. Leg squared plus leg squared equals hypotenuse squared. So that would be 8 squared plus 5 squared is C squared. 64 plus 25, which makes 89. Now we just need to grab a calculator real quick and find out what the square root of 89 is. Now, the answer square root of 89 is a great answer. We could leave it that way. I actually really like the answer square root of 89. But a lot of students are going to feel a lot more comfortable with hitting the square root button on our calculator and asking the calculator what it is. And I would say 9.43. Now over here, number 2, again, my legs, A squared and B squared, my legs are going to be the two next to the right angle, which would be 3 squared and 6 squared. And that's going to be equal to the hypotenuse, which this time, instead of calling it C, I decided to call it X. C is just a way that we all talk about it, but it can be any number. 3 squared is 9. 6 squared is 36. 9 and 36 makes 45. And now that means we could either say that X is the square root of 45, or we could take the square root of 45 here. Now, as a little foreshadowing to a later moment in our class, just like how you used to sometimes simplify square roots And you could take a square root and make it you used to like simplify fractions, excuse me. You take something like 4/8 and reduce it down to 1/2 or 12/15, and you see that the top and bottom are divisible by 3. We later on are going to learn how to simplify some of these roots. Okay, this one is a root that will be simplified at a later moment in the class. Now for 3 and 4, this is the kind that I'm actually seeing more issues with, when instead of the hypotenuse being the piece that is missing, it's one of the legs. So remember, it is leg squared plus leg squared equals hypotenuse squared. So I'd have leg squared plus leg squared equals hypotenuse squared. So if we were to subtract 16 from both sides, we're down to 84, and that makes y the square root of 84. And again, we can grab our calculator and we can come up with an estimate of 9.2 or 9.17. But that would be our value. So understand that it has to be smaller than the value of the hypotenuse, because the hypotenuse has to be the largest. Now this last one that I have, again, the legs would be 12 and z. They're the ones that are right next to it. So again, leg squared plus leg squared equals hypotenuse squared. Now, as it turns out, this particular time, I did something very nice, because if I work on this thing, I think I got the right one that I was hoping for. I subtract it, I get 81. When I subtracted 144 from both sides, I go to take the square root, and I got a nice number. So anytime you get a set of nice numbers that are nice whole number values, those are called Pythagorean triples. They're really pretty, and there's a lot of them, and they're very, very useful in industry. People use them all the time because of what we are going to look at next. And that says that if the Pythagorean theorem works, then it must be a right triangle. So an example of this would be leg squared, and this is a question. Is this true or is this false? Now remember, the hypotenuse is always the longest side. So is it true that 9 squared plus 12 squared equals 15 squared? That's a question. Is it true that leg squared, but in this case, leg plus leg equals hypotenuse, this has to be the hypotenuse. So I could say 10 squared plus 6 squared is 11 squared. I'm asking, is that actually a true statement? And we're going to find out, is this actually forming a right triangle? So 9 squared plus 12 squared. The question, is that 225? And we'd find out that the answer is yes. So since they do work, then it must be a right triangle. So if I'm building a sidewalk and I measure 9 feet, and then 12 feet, and as long as I come across the diagonal and I have 15 feet, I will know that I have produced a right angle, which would be really nice if I'm trying to make a nice square sidewalk, or maybe I'm forming up the concrete for a shed or something like that. People in construction use Pythagorean triples all the time. So could we use 6 and 10 and 11? Let's find out. Would that also be another way that I could make a nice right angle? Well, 10 squared is 100. Is 100 plus 36 121? Well, clearly that answer is no. This is not a right triangle. This is a right triangle. In fact, what's funny, I wasn't planning on talking about this. These two are too big. You know what that means? That means the hypotenuse is too small. This means it's underneath. It's too small to be a right triangle. If the hypotenuse was too big, it would make it too big to be a right triangle, and therefore it would be an obtuse triangle. And we'll talk more about that in the class later, but that's a little foreshadowing to another moment in time. All right, hopefully that helps studying the Pythagorean theorem. Remember, as always, leg squared plus leg squared equals hypotenuse squared. I will see you guys back in class. See you later.